Okay, so let's go ahead and get started. The reason that I gave you this this blank periodic table is because at certain times I'm going to have you fill things in on here. You do not get to use this for the test. This is just a study tool to help you get ready for the test, all right? So it's just a blank periodic table that you can fill in some different parts as we talk about the different parts of the periodic table, okay? So we're going to cover as much of this as we can today. We'll see how far we get, and then we'll finish it up tomorrow, maybe do some practice tomorrow, and then we'll study for the test on Friday, okay? That's the plan for now. We are out of here. What time are we out of here? 23. Okay, you know, we've got 10 minutes, right? Yeah, about 10 minutes. All right, so the periodic trends. First of all, periodic law, Mendeleev, I don't know. I'll just call him Dimitri. How about that? Yeah, I've never known how to say that, which is horrible because I teach this every year. But Mendeleev, okay. Mendeleev. It's like Christmas Eve, right? It's the eve of Mendel. I don't know what Mendel is, but anyway. Mendeleev. Okay, fine. I'm going to call him Mendeleev. Yeah, because I feel like that's probably not right, so I'm going to call him that. All right. His name is Mendeleev, all right? So it's going to bother you now. He was the first one who kind of took all of the elements. Now, people had tried to do this before. Scientists had tried to organize the elements into some systematic way so that they made sense in a chart or a table. He's the first one who did it really well, okay? Kind of worked. So I didn't know this, that he was perpetually in trouble with the Russian government. That's kind of interesting. I guess the Russian government didn't like him and with the church, but he was brilliant. Nevertheless, I like that. I'm going to put dashes in nevertheless from now on. And there's Mendeleev. All right? He had a lot of hair. Yeah, that's true, actually. All right. Okay, so he did such a good job with his periodic table. He was so confident in his arrangement that he was able to say he left gaps in his periodic table. And he said, look, you're going to find these two elements, and I'll tell you exactly what they're like, okay? And I cannot remember exactly which two elements. I'm pretty sure gallium was one of them. Yeah, Ga. It's a metal, but it's a really soft metal. At room temperature, it's a solid, but if you put it in your hand, it will actually start to melt in your hand. It will liquefy because it's just got such a low melting point that your body temperature is enough to melt it. So that's kind of fun. I think that that's one of them. And then I'm trying to remember I don't remember what the other one was. But there were a couple of elements that he predicted, okay? And he said, you're going to find these, and these are the properties they're going to have, and he was right, okay? Oh, these aren't, so these are just history, background. He understood the periodic law, okay? And the periodic law states this. Well, he sort of understood the periodic law. That's not entirely true. The whole atomic number thing he didn't know about because he actually developed his periodic table before protons were even discovered. So there was no atomic number when he developed the periodic table. He did it in terms of increasing mass. Basically, he just took the masses of everything and he lined it up. You could almost do this if you knew all the properties of the elements. So he lined it all up in a straight line. And what he noticed was there were certain times when the properties started to repeat. Every time the properties started to repeat, he started a new row. So he just arranged them in terms of mass, started a new row every time they repeated. And it worked really well for him, okay? And so then what he basically said was, he said everything on my periodic table in the same column has the same properties. Okay? Mendeleev. Mendeleev? Yeah. Mendeleev. I'm impressed that you looked that up. All right. Can you play it loud so that I can hear it? But where is that? Is that like a computerized thing that just phonetically pronounces words that you put into it? Okay. Yeah, I don't know. I'm gonna stick with Mendeleev, just because I don't want to say Mendeleev every time. It seems like too much work. Okay, here's the point. When you arrange these things by increasing atomic number, there's a repeating pattern. Okay, and what that means is lithium. We're gonna have to do this after Christmas break. Maybe we'll have time before Christmas break. When you put lithium into water, it sort of bounces around and dances a little bit. It's doing a chemical reaction, okay? Pure lithium in water. You put sodium into water, it catches on fire in the water. You put potassium into water, it explodes and catches on fire in the water, okay? They all react with water. That's lithium, sodium, potassium, all down that first column on the periodic table. So they all do similar things in water, okay? So that's an example of that repeating pattern where they all show the same properties, okay? So you look down any column on the periodic table, anything in the same column is going to have similar properties. So beryllium in the second column is going to have similar properties to magnesium, calcium, strontium, barium, radium, all the way down, okay? You look over here on the far right, you remember we talked about the noble gases the other day? You guys remember from 8th grade why they're called the noble gases? Yeah, I know. The noble gases are called noble gases because they don't react with anything on the periodic table. They're noble. They don't mix with the commoners, right? Okay. They don't even react with each other, okay? So, which is a little bit, well, never mind, okay. I'm going to make a historical commentary, but, so that last column there, they all have similar properties that they don't react with anything because they're in the same column, okay? Does that make sense? I'm going to go on even if it doesn't because no one said anything. Okay, so atoms of similar properties appear in groups or families, okay? And those are the vertical columns on the periodic table. You're going to need to remember the difference between a group and a period on the periodic table. So notice, group, you can't see that very well. It has the word up in it. Group has the word up, so a group is an up and down column. Okay, so that might help you to remember a group is vertical. Okay. And the reason that they're similar is because they all have the same number of valence electrons, which we are going to talk about as soon as we get back from Christmas break. Okay. Valence electrons just means the outermost electrons. And you may have even talked about that in 8th grade, but again, we've already established that not much of that stuck. So we'll talk about it again when you get back from Christmas break. So really, the number of valence electrons something has is what determines how it reacts chemically. Okay? Now how are we doing on time? What time? 23 is when we get out? Okay. So maybe one more slide here. Oh, never mind. We're going to talk about it now. This is on the notes. Okay. Do you remember how to tell the number of valence electrons for elements in the S and P blocks? No, you don't, because we didn't talk about it yet. Okay? So actually, you know what? I think we're going to skip over the valence electron part. So we'll stop there. We'll skip the valence electron part, and we'll pick up on letter B on the notes starting tomorrow.